Okay, welcome back. This is our fourth snow day video on simplifying radical expressions. And today we're just talking about the difference between radical form and exponential form. And tonight your answers have to be given in both forms. Now, if I write the cubed root of x squared, remember that x squared is called the radicand and 3 is called your index. We take the exponent of the radicand and divide by the index. So exponential form is written as x to the 2/3 power, or x to the 2/3 power. Let's practice another one. If we write the cubed root of x, the cubed root of x is written as x to the exponent underneath is unwritten. This is assumed to be a 1. Okay, so we say that x to the 1 divided by 3, or 1/3 power. Okay, square root of x is x to the, well, we have a 1 underneath, and the unwritten index is a 2. Even though it's not written, we assume that this is a 2 for square root. So this is x to the what? X to the 1 divided by 2 power, or x to the 1/2 power. And square root of x to the 3rd, again, this is your radical form, and over here we have our exponential form. Square root of x to the 3rd is written as x to the 3/2 power. Okay, so now, the concept with this lesson is to go from one form to the other. I have 4 examples to show you, and both forms have to be given. Now, in your radical form, you have to actually simplify or take out groups. Exponential form ignores groups. So remember this, radical form, you have to take into consideration groups, or take out the groups. Okay, in the radical form, take out the groups. In the exponential form, exponential form ignores group. All right, so let's look at these examples. 9 to the 2/3 power is given. 9 to the 2/3 power. Okay, so this is given in exponential form, and this is just like the first problem on your homework. What you have to do is convert this to radical form. So we're going to write this as, okay, let's look at what are we dividing by. The number on the bottom is your index. So go ahead and write index. Okay, the number on the bottom is the index, so we have cubed root of what? Cubed root of 9 squared. So we go backwards. This is cubed root of 9 squared. And now, notice 9 squared. We can now simplify the radical form. So once you get radical form, you actually have to simplify this down. 9 squared is 81. So we end up with the cubed root of 81. And now, we take out groups of what? Groups of 3. Okay, so we're going to take the 81 and break it down. Take 81 and divide. Well, we know that 81 is 9 times 9. Break this down. We have what? 9 is 3 times 3. 3 times 3. So we have 4 3's multiplying to give 81. We can write this as the cubed root of what? The cubed root of 3. Notice there are 4 of them, so 3 to the 4th power. And they now take out groups of 3. Since we're taking out groups of 3, and we have 4 3's total, how many groups of 3 can we take out? Hopefully you say, well, there's only one group of 3. Notice, if we write 3 to the 4th as 3 times 3 times 3 times 3, and we circle a group of 3, okay, every group comes out and becomes what? Every group comes out and becomes 1 on the outside. So 3 3's will actually become only 1 3 on the outside. So we end up with, on the outside, we have a 3. And notice underneath the cubed root, we're left with an extra 3. Okay, the 3 that's not circled is left underneath the cubed root, and this is your final answer. We call this, up here we call this radical form. And down here, this is called simplified radical form, meaning that you took the groups out. Simplified radical form. And over here is your exponential form. Now, the tricky part about this exponential form, the tricky part about this is that the SOL will ask you for answers given in all 3 of these forms. So you have to be able to convert between any one of these 3 forms. So on your paper tonight, I want all 3 forms labeled. Pretty simple. Now, let's look at an example just like your second problem given here. A little bit easier, actually. Okay, so we're looking at something just like problem number 2. So we're looking at here x to the 8/5. Okay, remember the bottom number is our index. Go ahead and write index. And we're looking at what? 5th root. Okay, the index goes on the outside. 5th root of x to the 8th power. So remember, This is 8 divided by 5, or written in exponential form as 8 over 5, so you should be able to go from one form to the other. From exponential to radical, you're also going to have to go from radical form back to exponential. Now, once we get to radical form, we have to now take into consideration groups, or take out the groups. Notice we want to take out groups of 5. Well, we have 8 x's. Can we take a group of 5 x's out of 8? Absolutely. So we have what? Fifth root of x to the, well, hopefully you can just see it. There are 5 x's. There is a total of one group in 8. So if we take out a group of 5 x's, remember every group comes out, becomes 1 on the outside. Since we only have one group of 5 x's, we're only going to have one x on the outside. I will visually show you again, x times x. If you have 8 of these things, hopefully by now you're starting to get the concept of this. There's 8 of these things. If we circle 5 of them, okay, 5 x's come out, become what? 5 x's come out, become a single x on the outside. So you have a single x on the outside. What's left under the fifth root? Well, there are 3 extra x's left. So we have x to the third left underneath the root. So our final answer is x, fifth root of x cubed. Circle this. Okay, this is your simplified. You don't have to necessarily label each form. I'm just labeling it on the video. Simplified radical. Oh. Simplified radical form. Okay. This is your radical form. Here is your radical form. And over here we have what? Exponential form. Okay, so this is exponential, this is our radical form, and this is our simplified radical form. Remember, simplified means the groups have been taken out. Next problem. Okay, so now we're looking at an example just like the third example, or third homework question. Let's see. So I have here the cubed root of x to the 8th. Okay, so this is the problem given. What you need to do is take the radical form and convert it immediately to exponential. Okay, so cubed root of x to the 8th, this is x to the what? We take the exponent underneath and divide by the index. This is x to the 8 over 3. And notice we are done. We have written our exponential form. Now we have to take the radical form and simplify it. So remember, this is your radical form. This is your exponential form. And now we have to get to simplified radical form by taking out groups of what? Groups of 3. Now in this case, we have more than one group of 3. There are 8 x's. How many groups of 3 are there in 8? Hopefully you say 2. And the way you figure this out is to go to the next number below 8 that's divisible by 3. What is the next number below 8 divisible by 3? Hopefully you say 6. 6 divided by 3 gives 2. So if you just think the next number below 8 that's divisible by 3 is 6, and 6 divided by 3 gives 2, that is your new exponent of x on the outside. And what are we left with under the cubed root? Well, since you took 6 x's out, or you took 2 groups of 3 out, you took a total of 6 out, there are 2 x's left, or x squared left underneath. I will show you visually one more time. There's 8 x's, okay? 8 x's. Once you get the concept, I think it just makes sense. There's 3 x's, 3 x's. There's 2 groups coming out. Remember that each group forms what? Each group forms an x on the outside, and we multiply these together, so we get x times x gives x squared on the outside. And what is left underneath the radical? What's not circled? We have 2 x's not circled, so left under the cubed root is what? X times x, or x squared. And this is your simplified radical form. The most important of the 3 forms on the board is the simplified radical form. Okay, so this is definitely the most important form. And lastly, we have a problem just like your fourth homework problem, pretty much identical. We're looking at x square root of x to the 9th power. And remember, our index, if it's unwritten, our index is a 2. The square root has an index of 2. So we write this as, remember, take the 9 and divide by the outer index. Okay, so this is 9 over 2. This is your exponential form. On the board given is the radical form. And now you have to take out your groups to get your simplified radical form. Now, since we have 9 x's, we're taking out groups of what? Groups of 2, or we're taking out pairs. Hopefully at this point you can see how many pairs are there in 9. If you're having a hard time seeing this, write it out and circle them. But I'm just going to talk through it at this point. How many pairs are there in 9? Again, go to the next number below 9 that's divisible by 2. Okay, the next number below 9 that's divisible by 2 is 8. And what is 8 divided by 2? 8 divided by 2 gives what? 4. So we have x to the 4th power, which means we took out 4 groups. Okay, 4 groups of 2 came out. Now, 4 groups of 2 makes a total of 8 x's that came out. So how many x's are left under your square root? Well, if you took 8 out, there's only 1 left. And this is your simplified radical form. Let's see, simplified radical form, the most important form on the board. And that concludes this video. So only one more video, and I look forward to seeing you guys when you guys get back from the snow days.